Sorry. All right. We have got this array of 7 locations, and another array of same sort but less number of locations. Idea behind this is odd number of locations and even number of locations. So binary search, first of all, you need to understand that it is unlike linear search where we search every single item. Secondly, array has to be sorted in ascending order. तो लेट्स से हमारे पास A है, B है, C है, D है, E है, G. And over here we have A, B, C, D, E, and F. So by the word binary, what do we mean is that this array will be divided into two equal parts. This array will be divided into two equal parts, and then it will be decided that whether the data is at the center of those two equal parts or in the middle of those two equal parts, or it would be in first part or the second part. So this is lower bound, this is upper bound. So first we will calculate the middle. How do we calculate the middle? Lower bound plus upper bound div 2. Why div? What is div? Whole number. Let's see if it works. Otherwise you will have to divide by 2 and then apply integer function. So 1 plus 7 div 2, 8 div 2. What's that? So this 4 will be the middle. Okay? Let's say we want to look for F. We are looking for F. So we calculated the middle by this formula. There might be other formulas as well. Then if it would be an odd number of elements, middle would be on some position. If it would be even number of elements, middle would go to the position one less. 6 plus 1, 7. 7 diff 2 would become what? 3. It would go there, one less. So whatever it is middle. Then we have to compare the value with the middle. If the value at the middle is less than the value to be searched for, what you would do, you will bring your lower bound to middle plus 1. Now this is your lower bound, 5. Then 5 plus 7, what is that? 12. 12 diff 2, 6. You reach to 6. Now your middle is 6. You look for the value. If it matches, okay, it is found. Now you might be asked to calculate the number of times if it was linear search and number of times if it is binary search. You search for F in 2 goes, 2 turns. Had that been into linear, it would be found in 1, 2, 3, 4, 5, 6 times. Since it was binary, we found it in 2. Okay? Second time over here, your lower bound would be 4. 4 plus 6, 10. Diff 2, 5. 5 will not be found. So you'll bring your lower bound from 4 to 6. 6 plus 6, 6 is lower bound as well as 6 is upper bound. 12. 12 diff 2, 6 found. If 3. ऑड में हमारे पास हमेशा नंबर ऑफ टर्न्स जो है वो एक कम होता है because of the ability to have it right in the middle. Now, if it is not found, what would happen? If it is not found, let's say we were looking for G and we were here. So lower bound would become middle plus 1, 7. So we have to put a check. If it is a while loop, we would have to put a check while lower bound is less than or equal to upper bound. It would go on. Or as soon as lower bound becomes greater than upper bound, it means it is not found. Now it is in an impossible condition. Is it clear? So we calculate a middle. We check if it is at the middle. If it is not at the middle, then is it less than middle? Then bring upper bound, middle plus 1, middle minus 1. If it is beyond the middle, forward, then we will increase the lower bound. We increase the lower bound, we decrease the upper bound. We increase the lower bound by middle plus 1 and we decrease the upper bound, middle minus 1. Okay? Now, this is one legit algorithm. Input value to search. This is an alphabet array. While upper bound is greater than or equal to lower bound. Or is found is equal to false. Is found is something good. As soon as we found it, we need to break the loop. If we don't do it, even after searching, it will go on until upper bound is no more greater than lower bound. Middle, this time I calculated middle by upper bound plus lower bound divided by 2 integer applied. By applying integer, we mean here to shed off any decimal part. If alpha middle is equal to this, then found is equal to true, output found at middle, and if, and while will break the loop out because is found is no more false, it is true. If it is not, then it checks that if middle is less than this, then lower bound is equal to middle plus 1. Else, upper bound is equal to middle minus 1. And if, and while goes back and recalculates the middle and keeps doing it. At the end, when it comes out for any of the two reasons, whether it is found or if it is not found. This is not found, this is found. Okay? Then it comes out, and if it is found, flag would be true. If it is not, flag would be false. Let's see in Visual Basic how it works. Get the gist of it, right? We have to calculate middle, and then we look for the data at the middle. If it is at the middle, it will always be. If it is in the array, it will be found at the middle. If it is not found, then we have to check whether we need to bring upper bound down or we have to take this lower bound up. Okay? And it is always middle minus 1, middle plus 1 for the reason that middle itself is checked already. Okay? These codes are uploaded. Binary search. I need to write the code. I have a code but with recursion, so let me write the code simple. Now what? What is this backslash? This backslash is for, this is div. This backslash is for div. All right. This code. Now this is same code. This backslash stands for div in VB. For mod, this is a keyword mod, but for div, it is a backslash. So this is simple code. So let's say we are looking for H. Okay. So it would work definitely. 7. We are looking for B. So it is at 1. It is starting from 0 anyway. So what's happening? And let's say if it is for Z, see, there is no control of it. Uh, एक नहीं हो रहा. Anyways, देखें. So let's say we are looking for H. Again, value is H. C means character type. Lower bound is 0, upper bound is 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8 values. Calculated middle, 0 plus 8 is 4. It is E at 4. Value is H and it is E. It is not less, it is greater. So our upper bound would now be 5. Alright, so it is now starting from 5 and ending at 8. Upper part is eliminated. And if, and while, then comes again, and this time it is 8. 6. Why? 5 plus 8. What is 5 plus 8? 13. Diff 2, 6. It is G. H is less than G. Lower bound is again refixed. Now middle is 7. It is found. Okay? And it will be now on screen. H found at location 7. Now look at this code. This is the same sort code, but this is recursive in nature. See what's happening. Doing the same, but it is calling itself. What is the name of function? Binary search. So you transferred array as parameter, upper bound as parameter, lower bound as parameter, and the value to be searched as parameter. And the value to be searched as parameter. Then we have dim, middle. If lower bound is greater than upper bound, then return -1, not found. else middle is equal to upper bound plus lower bound divided by 2. This is same. Select case. Now instead of if, I have used the case. Case is this, the value of the array. If case the value is equal to this, return the middle. Case is if the value of the array is greater than this, then we have recalled this again, but with the upper bound adjusted. Similarly, if the value in the array is less than this, then we have recalled this variable again, function again, with the lower bound adjusted. It is happening the same way. So it is returning the middle point. If it is found, it is returning -1 if it is not found. So let's see if it is working. All right. And let's say Z not found. All right. So it is working. This is made, I think, I don't exactly remember, but such type of question appeared in past papers somewhere in 9691. 9691. It is old question, very old, 10 years or 12 years old question. Yeah. So be careful. So that is how it works. The binary